Okay, let's look at the homework 7, problem number 8. Right? Helium is pumped into a spherical balloon at the constant rate of 4 cubic feet per second. How fast is the radius increasing after 2 minutes? All right? And also, at what time is the radius increasing at the rate of 140 feet per second? All right, so let's look at that. All right. So let's say, since it's a spherical balloon, so this is a spherical balloon, we know that the volume, so this is a volume formula, it's I believe it's a 4/3 pi r cubed, right? So we have that, and it's actually the helium is pumped into it at the rate of 4 cubic feet per second. So it actually tells you that the rate of change of the volume V with respect to time is constantly 4. Alright? And the question is, how fast is the radius increasing? So we are looking for dr radius with respect to time, dr over dt. So this is what we are looking for. So I'll say that. Then after 2 minutes, right? So volume can be also written as V is equal to 4 times T, because every minute it's increasing at the rate of 4 cubic feet per second, right? So 4T. So after 2 minutes, let's see. So V of 2 minutes is 120 seconds, right? Is going to be 4 times 120, so it's going to be 480. Right? Then we want to know how fast is the radius increasing. Right? So let's look at this volume formula and take the derivative. So if you take the derivative of volume with respect to time, you will get, right? So 4/3 pi is just a constant, so I'll just write that down. 4/3 pi, right? And the derivative of 3 r cubed would be 3r squared. Then multiply by derivative of r with respect to t. So we have to use a chain rule, right? So we can clean that up a little bit. 3 on the bottom and the 3 on top cancel out, so you end up getting 4 pi r squared and dr over dt. Right? Then we know that this is going to be equal to, right? So we know that the dv over dt is 4, so we set that equal to 4. Alright, then let's just simplify. So we want to solve for, first we're gonna, let's see, we want dr over dt, so divide through by 4 pi r squared. So we'll get the dr over dt, which is what we are looking for. And so it's a 4 divided by 4 pi r squared. Alright, so you can cancel 4's, and you end up getting 1 over pi r squared. Right? Then what we need to do is we need to find r. Right? So we know that after 2 minutes, volume is 480. So and also formula is 4/3 pi r cubed. We know that at that time volume is 480, right? Then we can just divide through by 4, and it's going to be 120, and then multiply both sides by 3, then you have a 360, right? So we can just divide through by pi to get r cubed, which is 360 over pi. Right? Then I'm going to just take the cube root of both sides. So r at the time is going to be equal to, I'm going to write it as a 360 over pi to the 1/3 power, right? So that is r. So we're going to plug this guy, let's see, plug this guy in here to get the value, right? So dr over dt is equal to 1 over, and there's pi, and 360 over pi, raise it to the 1/3 power square, so it's a 2/3 power. Alright, then we want to get the round this 4 decimal places, so let's compute that. Alright, I'm going to just bring out GeoGebra. So the value is 1 divided by, and pi, and also let's see, I'm going to have to put another 360 divided by, and pi, raise it to the 2/3 power. Alright, so let's see, so that's the value we want to get, so I'm gonna hit enter. Oop. Alright, let's see, oh, they don't like my pi, huh? So here, I'm gonna have to get this. Pi is, there should be pi. Where is pi? Is this the pi? Yeah, I guess this is the pi. Here's, oh, actually, I found it here. Pi, and then this is over pi. Right, so then hit enter. Alright, so I need to look at, let's see, 4 decimal places, rounding 4 decimal places. Right, so it's a 0.0135, 0.0135. Right, so let's put that in there. Let's see, I'm gonna open that up. Right, 0.0135. Right, let's check the answer. All right, so we got this one. All right, select the correct choice below if necessary, fill in the answer. Okay, so the time at which the radius increases at the rate of 104 feet, 40 feet per second is, all right, so let's try to do this. All right, so let's see, so that's the second question. All right, so the radius increasing at the 140, so let's see, we have done so much work here, so let's use it. All right, so this is a dr over dt right here, and we want this value to be 140 feet per second. So we're going to set that equal to, so 1 over pi r squared is equal to 140 feet per second. All right, then at what time? So we have to, okay, so this is going to be equal to, we're going to solve for r. So take the reciprocal of both sides. So pi r squared is equal to 1 over 140. And then divide through by pi to get the r squared is equal to 1 over 140 pi. Right, then we can just take the square root of both sides. So r is going to be square root of, I'll just write it 1 over 140 pi to the 1/2 power, which is the same thing as taking a square root. All right, so r is that value. Then we want to know when, right? So we know the volume is 40 and also 4 over 3 pi r squared. So I'm going to set 4t is equal to, all right, so that tells you that volume after t second, and we know that r has to be that value. So it's a 4 over 3 pi, and we have to raise it to the 3rd power. So it's a 1 over 140 pi raise it to the 3/2 power, right? So then we just have to find t. So this is going to be, right, divide through by 4. So t is going to be equal to, 4 cancel out, so it's going to be just pi over 3. And 1 over 140 pi, and raise it to the 3/2 power, right? So let's find that value. Let's see, what's the precision they want? They want, let's see, 5 decimal places, right? So let's do that. Let's see here. All right, so I'm gonna just find that value, right? So it's going to be pi, oops, all right, pi over 3 times 1 over 140 pi, raise it to the 3/2 power. All right, so let's see, so it's a 1/3. Let's see, I'm gonna make sure that it works properly, so I'll just put the parentheses. So it's pi over 3 times 1 over 140 pi, raise it to the 3/2 power. So make sure I'm gonna put the parentheses there. All right. So let's hit enter. All right. So it came out to be 0.0035. Right. So let's type that in. Right. It's 0.0035. Right. That's a really small number. Let's check the answer. Right. Let's see. So it says that try to find a time t such that the error is t second. Okay. Right. So maybe I did something wrong here. Let's see. So t, you're looking for dr over dt is equal to 140. So we got that. And t is equal to not sure why this is not working out right. All right, I'm going to I'll do the computation again. So I think I might have messed up the computation. Yeah, sorry about that. So it's a pi over 3. I think this is right. Let's see. It's a 1 over 140 pi. Alright, so I'm going to put the extra and raise it to the 3/2 power. Alright, so hopefully this will produce a different number. Alright, so it came out to be 0.001. I'm not sure. So let's try, let's see, 001. Alright, so let's check the answer. Alright, so that's not right. Oh, because it's a 5 decimal places. Okay. So option rounding 5 decimal places. It's 1 1. Huh. Alright, so let's final check. Okay, got it. Alright, seems like sorry about this. Seems like the computation was correct, but I think I put the computation into the GeoGebra wrong, and it was 5 decimal places as well. Alright, so that's it. I hope that this was clear.